All right, hey everybody. I want to go through the last example from the slides. I said I would do an extra example that we didn't get to in class. So here is a similar example as the Canada CO2 emissions problem. So in this case, we're dealing with the number of internet users in South Africa, and we're told that they have been increasing at a constant rate since the year 2000. And what we know are two data points. So on the one hand, I know in 2002, there were 3.1 million internet users in South Africa. And then in 2004, there were 3.5 million internet users in South Africa. So we've got two data points, and we want to fit a model based on these two data points. And one really important thing to note here is that because this increase is at a constant rate, this is what tells me we should use a linear relationship. So we're going to have a formula here, and what we have is n as a function of t, years since 2000. So in the end, what we're hoping to get is n is going to be some function of time. And because it's linear, that function should be able to be expressed in slope-intercept form as b plus mt. And with our two data points, hopefully we definitely can figure out what the value for b and m are. So what are our units here? So we have input, which is t, and this is measuring years since 2000. And then we have an output, which is n, and that's that would be the millions of internet users. And so we've got 2 points that are given to us. And so the point corresponding to in 2002, there were 3.1 million internet users. Well, if I were to write this out as a point, then what is the value of t? Well, t is years since 2000. 2002, right, would be 2 years later. So t is equal to 2 in 2002, and the corresponding value for n is 3.1. And then we have a second point in 2004, right? That would correspond to a t value that is 4, and we know that the corresponding output number of internet users was 3.5. So now this becomes a problem similar to the Canada example where given 2 points, let's find a linear model corresponding that would pass through those 2 points. So here we're going to work on question A, but I'm going to head over to the next slide in order to do that. Okay, so what we know is that this relationship between t, the years since 2000, and the number of internet users in South Africa in millions is linear. So it's going to have this form. And on the previous slide, we identified that here was 1 point to 3.1. That corresponded to the amount in 2002, and in 2004, this was the point. So we have these 2 points over here, and our goal is to find a formula for the line that goes through those 2 points, which I've sketched in red over here. So if we want to find the slope, we can look at the change in the number of internet users over the change in time. So the slope m is, remember, the change in the output, and our output is n, divided by the change in the input. So we can take n1 minus n0 and then divide by t1 minus t0. And now I'm going to plug in my values. And so we have that n1 is 3.5. And if I want to make sure I'm doing things correctly. I should have outputs on the top. So 3.5 is the output. And then I want its corresponding input value should be the first thing that we therefore see below the fraction, in the bottom of the fraction. And then we're going to take a difference. And we would take n0, which is now 3.1, and then we're going to divide by 4 minus, and our initial value for t0 was 2. And so doing the calculation here, this would give us 0.4 over 2, which is 0.2. So this tells us that the slope m is 0.2, and the units of this 0.2 would be millions of internet users per year. Great, so now we've got one out of the two parameters in our formula that we were setting up. So we know that the slope is 0.2. Got that over here. And what we still need to find is the vertical intercept. And so be careful, the vertical intercept is not the first data point that we're given, right? The value for B is going to be the value of the output n. So that's going to be how many internet users were there when t was equal to 0. And we can identify that point by looking at where does the graph cross the vertical axis. So that would be this point over here. So we're trying to find what is the value of n, not the first data point that we're given, but exactly when t is equal to 0. So in this case, we're not given the number of internet users at year 0, but we can use either one of these points to figure out what b is. So let me take this point over here, and this tells me that when n is 3.1, the value of t is 2. So I'm plugging in that t is equal to 2 right over here, and n therefore should be 3.1. And now I have an equation, and what I need to do is solve this equation for b. So this tells me that 3.1 is equal to b plus 0.4. And now if I want to solve for b, I want to subtract this 0.4 from both sides. Okay, so be careful. Since I'm adding it on the right side, if I want to just solve for b, then I'm going to subtract 0.4 on both sides. So on the right side, when I subtract 0.4, all I get left is the b. And on the left side, when I subtract 0.4, what comes out is 2.7. So now I've got my formula. N is equal to 2.7 plus 0.2 times t. So that tells me in particular that this value over here, where the graph crosses the axis, is at 2.7. So here we've got our formula for this model, okay? And again, here we're modeling the number of internet users in South Africa in millions as a function of t years since the year 2000. Okay, and finally, I want to make sure that after we find this formula, we're able to unpack and interpret what the values in our formula are telling us in practical terms. So here was the formula that we found on the previous slide. And just recall that the output n is millions of internet users in South Africa, and t is corresponding to years since 2000. And so in general, the vertical intercept is going to be the value of the output when the input is 0. So when we're interpreting this, we want to just be sure we scrub this kind of generic-y, mathy terms of output and input, and we explain what these quantities are in practical terms. And so there are different ways that we could do it. Here's one suggestion. So this tells us that South Africa had 2.7 million internet users in the year 2000. So input being 0 is 2000. Value of the output, we explained that means South Africa had 2.7 million internet users. And for the slope, in general, the slope tells us by what amount the output changes when the input increases by 1 unit. So we found the slope of 0.2. And there are different ways that you could interpret this. So there's not a unique answer that I would be looking for, but one example of a nice interpretation of this slope would tell us that the number of internet users in South Africa is increasing by this amount, 0.2 million people, every time we increase t, so each year. Okay, so hopefully this gives you some additional examples to look over, get you going on your homework. Have a nice weekend, everyone.